This is complex numbers class 8. In this session, we are going to discuss about some topics. What are they? The first one is how to prove a complex number is purely real. And the next one is how to prove a complex number is purely imaginary. These two topics we are going to discuss today. For these two topics, already as I told you, I have given you an important clue in the properties of complex numbers, part 2. What are the properties? What are the main properties to prove the given complex number as a purely real one or a given complex number as a purely imaginary? It is very simple, but anyhow, you have to remember the points. Just remember the following points. The main point is this. If you want to prove a complex number as a real one, that is purely real, just you have to prove z is equal to z bar. That is, just take conjugate to that complex number, and if that conjugate is equal to the same complex number, then we can say the given complex number is purely real. The same way, if you want to prove a given complex number as purely imaginary, for that also you have to do the same thing. Just take conjugate to that complex number and multiply it by negative sign. And if your minus z bar, after calculating your minus z bar, if the result is the same given complex number, then it is proved the given complex number is purely imaginary. So these two are the key properties. If you have doubt in this, you can see your old videos, properties part 2 in the complex number. Moreover, we have to remember this formula, that is z1 minus z2 the whole bar is equal to z1 bar minus z2 bar, and z power n the whole bar is nothing but z bar the whole power n. These properties you must remember in your mind, and we have to proceed. Now let's go to a problem. Now we have to prove this complex number, this big complex number, as a purely imaginary one. How to prove this? It is very hard for us to find the value of 2 plus I root 3 the whole power 10. We cannot find it very easily. It is very big sum. So how to do this? As I told you, you don't try to expand it. It is a hard work. We can do it in another way. That is, first let's keep this complex number as z. So this complex number is kept as z. Now, as I told you, to prove this complex number is purely imaginary, you have to do only this. Just take minus z bar. If your minus z bar value is same z, then that complex number is purely imaginary. Let's try to do it. So let us try to find z bar value for this problem. Right. So taking whole bar to the left as well as the right side. We are going to take for left side as well as for the right side. Right. So this is z1 minus z2 the whole bar. z1 minus z2 the whole bar can be written as z1 bar minus z2 bar. So we can split this complex number into 2 like this. So this complex number is written now in this form, that is 2 plus I root 3 the whole power 10 and whole bar minus 2 minus I root 3 the whole power 10 the whole bar. Right, now this is in the form z power n the whole bar. How to simplify this? Right, there is a small formula, that is z power n the whole bar can be written as z bar the whole power n. So we can bring the bar inside the bracket. Same way, let us proceed with this sum. Now the problem becomes 2 plus I root 3 the bar and whole to the power 10. And for this 2 minus I root 3 for this bar and the whole power 10. Using this formula we can convert this in this way. Now this is very simple. For this complex number we have to take conjugate. So 2 plus I root 3 will become 2 minus I root 3 and 2 minus I root 3 will become 2 plus I root 3 while we are taking conjugate. So right, so we have taken this conjugate to this complex number, so there is no need of keeping the bar because bar says take conjugate. So for 2 plus I root 3 we can take an conjugate, so bar is gone. That's the way. So we have simplified this problem in this way. Now just listen, if you see this sum, that is this z bar value and z value, there is a small difference. This 2 minus I root 3 which is in the last place is in the first place, and 2 plus I root 3 which is in the first place is in the last place. So just interchange it. If you want to interchange these two, you know very well, if you want to change a minus b, we can write that as minus of b minus c. So we can simplify in this way. This is now in the front and this is now in the back. For that we have added minus. If you have doubt, you can multiply this. Minus into minus plus this part. Minus into plus minus this part. So the same thing is here, but the orders are changed. Now if you see, you can see the same thing. 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10. It repeats here. So instead of this, we can write z. So our z bar becomes z bar is equal to minus z. Right. So if you, this implies, that is changing sign on both sides, that is minus z bar is equal to z. So it comes under this category, that is minus z bar is equal to z. In this way we have proved it. So now it is clear, for a complex number, if it has this property, that is minus z bar is equal to z, then surely that will be purely imaginary. So it is crystal clear, this given complex number is purely imaginary. In the same way, let us try to prove some problems with purely real. Let us consider this problem. Right, 19 minus 7i by 9 plus I the whole power 10 and something the whole power 10. We have to prove this as purely real. So the same logic. What is the logic? We cannot expand this. First of all, let's try to simplify this. It is very simple. Inside the bracket we can simplify it, and let us try to make this as a ordinary simple complex number. Let's do that first. So the complex number is given by the name z, and we are going to simplify this term. So this term can be simplified in this way. As I told you, you should not have any complex number in the denominator. Take conjugate for the denominator and multiply with that conjugate to that complex number in the numerator as well as in the denominator. So 19 into 9, 171, 19 into minus I, minus 19i, minus 7i into 9, minus 63i, minus into minus plus 7i square. I square value is minus 1, so it is minus 7. Here there is no need of multiplying like this, because if this is complex, this is conjugate. To multiply a complex with its conjugate, the easiest way is real part square, that is 9 square, plus imaginary part square. Your imaginary part is simply 1, the coefficient of I, that is 1, that is 1 square. So 9 square 81 plus 1 square 1, 81 plus 1. If you simplify it, 171 minus 7, and if you simplify this two terms, that is I terms, your answer will be equal to like this, that is 164 minus 82I by 82. We can split it, 164 by 82 minus I into 82 by 82I. So it goes 2 times, it goes 1 time. Your answer is 2 minus I. So we have simplified this complex number and we have received the answer 2 minus I. The same way, let us try to simplify this part, that is 20 minus 5I by 7 minus 6I. So for this sum, we have taken conjugate, and multiplication is done for the numerator and for the denominator, and if we simplify this, your answer will be equal to like this, that is 170 plus 85I by 85. We can split it, your answer will be equal to 2 plus I. I hope so you can do it very easily. I don't want to explain it again. So this complex number is 2 minus I, and this complex number is simply 2 plus I. Just substitute there, your complex number is this. So this complex number and this complex number are same. So now don't worry about this, just try this sum, it is enough. If you proved it is purely real, then this is also purely real. Let us try to do this. Then how to do it? As I told you, whether to prove whether a given complex number is purely real or purely imaginary, the main point is to take conjugate to it. So we have to take conjugate to this, right? As you know the property, if you take conjugate and if you prove Z bar is equal to Z, then the complex number is purely real. So let us take conjugate for both the sides, for the left side as well as for the right side. So conjugate is taken. You know the property, we can split it. If you split it, your answer will be like this, because Z1 plus Z2, the whole bar can be written as Z1 bar plus Z2 bar. As I told you, this two can be interchanged. So the formula, the property is very well known thing to you, that is Z power n, the whole bar is nothing but Z bar, the whole power n. So using that property, we are doing like this. Bar comes inside and the power 10 goes outside. So this is 2 minus I whole bar whole to the power 10. This is 2 plus I. We have to take conjugate for this, then we have to take power 10. So just this is very simple now. 2 minus I. For this 2 minus I, we have to take conjugate. If we take conjugate to this 2 minus I, it will be 2 plus I. If we take conjugate for this 2 plus I, it will be 2 minus I. So the answer will be in this way, that is 2 plus I the whole power 10 plus 2 minus I the whole power 10. Conjugate is taken to these problems, right? If you say this, you can see the same sum here, 2 plus I the whole power 10 plus 2 minus I the whole power 10. So your conjugate is the same complex number. So that is Z bar is now equal to Z. The property says in a complex number, if Z is equal to Z bar, or if the complex conjugate is equal to that same complex number, then surely that complex number will have only the real part, that is, that complex number will be a purely real one. So we have proved this complex number is purely real. So this is very easy, but we have to remember these two properties. If you keep these properties in mind, you can do this type of problems very easily. Thank you.